Hello, everyone. Thanks so much for being with us today. I'm Shauna Wolferton. I'm the head of product here at Benchling. Super excited to come back to you with our second What's New at Benchling. We got a ton of great feedback that you really appreciated, our first one last quarter. So this is a thing we're going to do every quarter from now on. It's exciting. So you can always get the latest What's New. You can scan our QR code or always go to benchling.com/what's new. We know you're all very busy, and so we have got all of the best packed into a single hour today. We're going to keep it a little fun. We got some demos, some Q&A, a few polls in there. So feel free to ask questions through the whole presentation, and then we have some time at the end for Q&A. We have an exciting agenda today. We're really excited to walk you through how the Benchling R&D Cloud is helping researchers to advance their next generation science. First, we're going to share some new capabilities for designing, modeling, and studying both naturally and chemically modified mRNA and RNA, and it's achieving new breakthroughs in RNA. We'll share some improvements for modern sequence design and analysis, especially focusing on bulk assemblies so that we can help you do your work more efficiently. And finally, we're going to share some new great advances we have in our workflow tools that enable teams to design and execute complex processes using shared scientific data that they've generated in Benchling. And together, all of that is biology's modern limbs, and it's helping move your science forward. We're going to close with some Q&A, so please, like I said, go ahead and ask your questions in the box, and we will get to as many of those as we can. We have an amazingly great lineup of speakers here today, experts in our products, solutions, and our customer experiences. So we're going to dive in to our first webinar topic, and that is achieving breakthroughs in RNA. Well, the past couple years have been challenging for us all. It definitely taught an awful lot of folks about the power of the work you all do. We really didn't think, we couldn't have imagined that mRNA would be dinner table talk, but here we are. And RNA molecules are fundamentally changing our understanding of biology and how we address disease. And in talking to a whole bunch of scientists, I have learned that the tools that exist today for doing this work are incredibly limited. Zach, who's here today, as a scientific solutions consultant at Benchling, are you able to share some of your insights on this challenge based on your customer interactions?
Thanks, Shauna. You're absolutely right. In my discussions with current customers, they've revealed that traditional software is inadequate to address both the chemical and biological intricacies of RNA therapeutics. They find that their systems are low throughput, very manual and laborious, and ultimately disconnected from one another. All this adds up to considerable delays in delivering results and lower quality data. Grouping their challenges that I've heard together, I've come across three key areas where current solutions like spreadsheets and legacy LLMs are poorly optimized for these kinds of workflows. The first one is that the design tools themselves are very tedious to use, right? Again, there's no solution that unifies both the biological and chemical nature of RNA therapeutics with tools and features that our customers have come to expect from Benchling, such as seamless collaboration, analytics, and insights. Scientists chemically modifying these oligos, especially in spreadsheets, again, find that these are manual and low throughput. Secondly, there's no common taxonomy or syntax for these RNAs. Each vendor, from IDT to Eurofins to Thermo, whoever, maybe even internal systems, all have a different way to translate an RNA sequence into a single sequence, representing all the chemical modifications. This makes it very challenging to share sequences with one another across teams, or even externally with collaborators. And that leads me into the last and most painful point that I've heard from our customers, which is that the data themselves is very disconnected and siloed. Looking at the figure on the right, many of you may identify this in your current setup. You may have teams using all sorts of different software, such as ELNs, analytic tools, or other sort of chemical drawing tools. And there's considerable difficulty in moving data from one place to another. Again, whether it's because it's missing a taxonomy, whether it's tedious just to create these tools, or whether the teams themselves are just storing data in different formats. Fortunately, in developing our new R&D solutions, Benchling partnered with industry innovators. For the first time, R&D teams can design natural and chemically modified sequences, including mRNA and RNA oligos, in a single software solution. Addressing these three challenges, first, we wanted to enable faster RNA design. We wanted to make sure that you can iterate your chemical modifications faster. Secondly, we wanted to simplify collaboration. We wanted to provide a common platform where all teams, regardless of where they are in the R&D end-to-end workflow, could enjoy a unified syntax. Finally, we wanted to make sure that data was all centralized and available in one central location so that we could lead our teams to higher quality data and, of course, insights from those data. So I'm sure you have questions about all what this looks like and how this actually comes together in the platform. So I'm happy to now switch gears and actually jump into Benchling and show you how we've achieved some really great strides in addressing these key challenges that I just discussed with you. First, I'll play the role of an RNA scientist who just received results from their formulation team and needs to go back and iterate over new designs. We'll look at how Benchling's design tools make it easy for me as that scientist to not only view my modified sequences of mRNA, but also introduce new chemical modifications. Secondly, I'll show you how easy it is to also get the detail you need at both the biological sequence level, as well as the more detailed structures of those chemical modifications. We'll also see how we can search by chemical modification to make it easy to find what you're looking for. Finally, we'll extend our dive into chemistry by looking at how we can start building more complex entities that accurately represent the kinds of molecules our customers are trying to create and deliver as breakthrough therapeutics. We'll especially look at how we can conjugate an mRNA molecule to a chemical molecule of interest, and how the tools for mRNA can be extended to chemical conjugates. All right, so let's jump in. Welcome to Benchling. If you haven't seen this before, this is Benchling. Access just via my Chrome browser here. No need to install anything on my computer. I can just access this wherever I have an internet connection. I can again be capturing and reviewing my data. Speaking of which, I'm playing the role of an RNA scientist that's just been reviewing the recent data from our formulations team. And what you're looking at here is our Insights app, which really makes that easy because it aggregates all the data across our organization's database and pulls it in front of me and visualizes it in meaningful ways for me to make better decisions faster. Now, speaking of which, one of those decisions I decided to make based off this data is to refine our modifications on one of our mRNA sequences, namely this EGFP sequence. So what I've done is I've gone ahead and opened that up for us so we can dive more into this and understand how Benchling will make this easier for me. To orient you, if you haven't seen our molecular biology suite before, on the left-hand side is our sequence map. The sequence map, again, contains all the information about the biological context here, this primary sequence, any annotations, as well as translation. So here I can see this is our protein sequence, as well as the 5' UTR and exons as well. So as I mentioned before, our RNA solution encompasses both the biological and chemical context necessary for RNA therapeutics to thrive. And as I zoom in, we can start to get more and more of that chemical context here. And you'll start to see that there are certain bases or nucleotides here that have been marked with a certain symbol. And there's a legend at the bottom, but effectively, these indicate that these positions have chemically modified nucleotides. And if I want to understand what the structures of those are, I need only to hover my mouse over them, and Benchling shows me what they are. And Benchling knows which part of the structure is which in terms of the sugar base and phosphate. So for instance, if I hover over the phosphate, it shows me that and highlights that individual region. So you can see here we have a phosphorothioate guanine with the 2-O-methyl ribose as the sugar. And you'll see similar modifications throughout the sequence. So again, I have full chemical context here along with the primary sequence. So I can iterate quickly on these new designs and share them. And my team and I can all be speaking the same language or taxonomy. Now, on the right-hand side, we have all the wonderful metadata and information about this mRNA, such as who created it, what project is it in, what gene and protein is it related to, the plasmid that made it, et cetera. As we'll get to later in our demo, the chemical conjugate next with it. And finally, a very well-requested feature, the molecular weight for the sequence. Now, the molecular weight here, as it indicates, is modification aware, which means that as we make modifications, both natural and unnatural, to this sequence, this value will automatically be updated by Benchling to reflect those changes. Speaking of which, let's go ahead and start making them. Again, I just reviewed my data and I want to iterate on new designs for this sequence. So to do that, I can come over here to our nucleotides tab and begin viewing the sequence. Now, I can approach this in two different ways. I can make point mutations in small amounts, maybe tens or so of nucleotides. So for instance, if I wanted to mutate the first 10 nucleotides, I could just select them here, come over, and have Benchling change them all at once. So maybe I want to replace the sugar here with a locked nucleic acid and make that phosphate phosphorothioate. And it's that easy. Now I've got all those 10 positions updated. So if I scroll to the top now, you can see they've been updated here. And again, they reflect the changes listed on the right-hand side. It's easy to read. It's quick to identify that these have some sort of chemical modifications with them. And it would be consistent across my team's usage of the platform and our sequences. Now let's imagine that I actually want to go a little bit larger, more wholesale changes. I want to actually replace every cytosine in this sequence with 5-methylcytosine. How would I do that? Well, luckily, Benchling has a really great find and replace feature that is similar to what I've been using in things like Office, where I can come in and say, hey, Benchling, find every nucleotide with these particular parameters around the sugar base and phosphate, and then replace them with this sugar, this base, and this phosphate. Now, as I mentioned before, we're just going to replace every cytosine with a 5-methyl analog. And as you can see here, it's going to replace 269 nucleotides. And it does so in seconds. You can see here now, every cytosine has this purple shade behind it, indicating that the base is modified. And again, you can quickly grasp that detail both from the list view as well as just hovering your mouse over it to see the wonderful structure there. So, as I mentioned before, we can make these chemical modifications to the sequence either individually or more wholesale as we just have. Another really great feature in our RNA therapeutic solution is the ability to find sequences based on the monomers they contain. So for instance, if I wanted to, I could ask Benchling to help me find all the mRNA sequences that we're using that contain a specific monomer. Maybe this monomer has been shown to be really active in other sequences, and I want to understand which ones we need to continue with. So for instance, I can come in here and say, all right, let's look for maybe this locked nucleic acid that we just used. And we can find this at any position, or I could specify that I'm really looking at key positions, or there has to be a minimum or maximum number of this monomer in the sequence. And then once I put in those criteria, Benchling quickly turns around all the mRNAs in my database that have it. And of course, there's just this one that we've been working on. So Benchling not only makes it easy for me to find what I'm looking for, but it also makes it chemically aware as well, right? We can search on a monomer basis and we can know what that structure of the monomer is. Coming back to this metadata, if you've been paying attention, you've seen now that this value has now updated to reflect all the changes we made. What I want to do now is go a little bit deeper into this sort of chemistry detail. So if you've been following along on our webinar series, you may have learned recently that we've enabled chemistry as an option in our registry set now, where you can actually register small molecules. So for instance, I have this small molecule of enthermid as a chemical conjugate on this mRNA. And if I dive into that, you can see a number of different information, such as the physical chemical properties, again, any specific metadata we might be tracking, and of course, the actual chemical structure, which if I wanted to, I could edit on the fly here. Now, as you saw, we made it possible to find every RNA that had a particular monomer in it. In a similar fashion, we can also search every chemical structure or molecule we have for a particular substructure, right? A substructure search has been definitely something many of our chemistry-facing clients have been asking for. So to do that, I can, again, just use the same search menu I've been using this whole time. I'm not jumping around the different aspects of the platform. It's all in one spot. And when I open this up, you can see I'm greeted by this Marvin sketch editor that many of the chemistry audience would be familiar with. And what I'll do is I'll ask Benchling to find every registered molecule I have that has a phenol moiety somewhere in it. And in a few seconds, I have all the answers there. It looks like there are 98. And when I expand this window, I can actually see how Benchling pinged it. Oh, okay. This is where the phenol is. It's highlighted, it's clearly contrasted, and it's very easy for me to see the entire structure as it relates to what I was searching for. All right, so that's a wrap for our demo today. Again, in summary, you saw how Benchling's RNA therapeutic solutions can address the key challenges of the legacy systems. Our solution facilitates faster design of modified RNA sequences using a single taxonomy and all sits on a unified platform with the rest of your data, making it easy to share with your different teams that all need to come together to make your solutions and therapies come to life. If you're currently a Benchling client, take option 1 and go ahead and reach out to your account team to learn more about these features if you're not using them already. If you're not currently a Benchling client, go ahead and request a demo either here on the webinar or on our website at benchling.com. We're happy to reach out to you and see if this is the right solution for you. Finally, you can always read more about these features in our latest blog post, linked here on the right-hand side of the webinar. Again, thank you so much for your time. It's been a pleasure. Back to you, Shauna.
Thanks, Zach. That was a great presentation. For our attendees, if you have any questions about the new RNA capabilities in Benchling, feel free to enter them in the Q&A chat and we'll do our best to answer them. These new features to look at RNA are really exciting given the recent trends in developing RNA therapeutics. We've also been working on some new sequence design and analysis tools that can be carried out in bulk to improve the throughput and predictions. And Johan is here today, another scientific solutions consultant, and he's going to share an update with us. Take it away, Johan.
Thank you, Shauna. I'm happy to share some of the latest improvements we made to molecular biology and the registry. You've already heard about the new RNA capabilities from Zach, and I'd like to walk you through some of the new sequence design offerings that help to improve throughput as you scale your work and teams. I'll also touch on AlphaFold Beta for making predictions of 3D structures of your proteins. Benchling wants to be at the forefront to innovate with modern sequence design and analysis tools. In silico sequence design and analysis is at the cutting edge of science, which is evolving all the time. Sophisticated scientific concepts and data are often translated into newer approaches to improve sequence design or analysis. Additionally, once certain approaches are proven, scientists seek to leverage these approaches more broadly across their programs and teams to scale their research. Given the rapid pace of change, most in silico design and analysis tools struggle to keep up with new discoveries and changing needs of R&D teams. As a result, scientists have to rely on a multitude of point solutions or custom-built software for different parts of the workflow. Benchling continues to invest in cutting-edge technology to bring new intelligent tools to scientists, from bulk sequence design and analysis to machine learning algorithms and automation. Starting your research off with intelligent sequence design will lead to better predictions of results and more efficient use of time. Let's discuss how these new sequence design capabilities ensure high-quality scientific output and increase throughput for modern collaborative R&D teams. Molecular biology is Benchling's application for designing and analyzing DNA, RNA, and amino acid sequences. As part of the Benchling R&D Cloud, it is the intelligent design and analysis software for scientists working with complex biomolecules and assist you in deliver higher quality results. As you heard in Zach's presentation, we're excited about the new RNA capabilities available in molecular biology. You can also perform sequence confirmation in bulk. You can set up DNA alignments in batches to increase throughput and minimize repetitive and tedious activities. We've expanded the tools for searching, designing, and aligning sequences. Access AlphaFold Beta to leverage the latest AI algorithms to predict 3D structures of novel proteins. As your research evolves, you can standardize sequence designs and record them in the registry to reduce redundancy of work. Since Benchling's R&D Cloud is a single connected solution, it promotes more effective collaborations across projects and teams. Now let me walk you through some of these new features. We'll begin the demo by looking at some of our updates to our DNA alignment tool. We have made a series of updates to our DNA alignment flow that improve the experience of creating and configuring DNA alignments in Benchling. First, we released a new bulk alignment tool, so you can run multiple alignments once rather than one by one. Secondly, we added support for 2 new MAFTA algorithms, and we also added more parameter options in specifying how the alignment should be run. We will now take a quick look at these tools in the Benchling platform. I've now opened Benchling, and I'm looking at a DNA sequence called EDEM1. What I want to know is how EDEM1 aligns with EDEM2 and EDEM3, and at the same time, I also want to do an alignment of EDEM1 and some sequencing reactions that I have run. So to this end, I'll start a new alignment. I'll go to the create, and I'll specify a new alignment. When I start the alignment, I can search for DNA or RNA. So I'll search for EDEM. I'll select EDEM1, EDEM2, EDEM3. But I also, as I mentioned, have my sequencing reactions that I want to bring into this alignment. So I just simply drag them in, and you can see how the sequences come in here. I can also name a custom sequence and type it out here in case I want to add that to the alignment. I'll then click Next, and here we'll see the new options for our alignments. And there's a few new ones. For example, we could make a consensus sequence, which is you have multiple sequences and you're defining which is a consensus one. There's a pairwise system when you can have one template and many sequences, and you take each of those sequences against the particular template. But what we want to do now is a multi-sequence alignment. And here, we're going to specify templates and then run the different sequences against that particular template. So the first, I'm going to select EDEM1 because I want that as my template. And you can see that we're automatically pulling in all the sequences that we selected earlier. However, I don't want this because in the first alignment, I only want the EDEM1 gene with EDEM2 and the EDEM3 gene. So I'm going to remove my sequencing reactions. I am, however, going to make a new template of the EDEM1 gene. And here I can then add my sequencing files in a point-and-click fashion. And this will now run one alignment that compares EDEM1 gene to the EDEM2 and EDEM3 gene, as well as a separate alignment that aligns the EDEM1 gene to the different sequencing reactions. As I mentioned, we have new ways of doing alignments in benchling. As you can see here, we have six-mer, local pairwise, global pairwise, and so forth. And you can also then change the parameters and customize these, particularly gap open penalty and gap extension penalty. At the moment, I'm just going to keep this at a default level and then click Create Alignment. And when I do this, benchling will now run two separate alignments, one for looking at the comparison of the genes and one for looking at the sequencing of EDIM1. So here, when we select this particular alignment here, you can see here we are aligning the EDIM1 gene to the EDIM3 and the EDIM2 gene, which allows us to see the conservation of these different genes across alignment. We also have this second alignment that we made, where we simply wanted to compare the EDIM1 template to our different sequence interactions to make sure that they're all lined up, and it seems pretty good. This is a huge benefit because it allows me to do multiple alignments at once, which saves me a lot of time and reduces the chance of manual error. It is also allowing me to do different types of work and different types of analysis because I can now include and modify different gap penalties and get different gap extension penalties, or run the alignment as a sexmer or some other type of algorithm for defining these alignments. So this has been a brief demo of our new bulk alignment feature. Having had a look at our alignment feature, I now want to show you Benchling's new tool for protein structure. Given Benchling's focus on providing novel technology to support cutting-edge science, we're excited to offer limited beta access to protein structure prediction using AlphaFold. AlphaFold enables users to predict the structure of a given protein sequence and interact with the 3D structure directly in Benchling. We're now back in Benchling and we're looking at the amino acid sequence of a mice IgG molecule. What's new in this view is the 3D structure tab up here. When I select this tab, I can see a 3D representation of this protein structure, and I can rotate it around and I can interact with it. If I select some of these amino acids, for example, on these beta sheets, I can see how the different amino acids are oriented, and I can see where different hydrogen bonding might occur. We also have multiple measurements that we can do, such as distance and angles, and you can then also change to an illustrative sort of space model of this IgG structure. And the great benefit here is that you can modify and investigate and look at your model in the same platform as you do your other work. That was a brief look at some of our latest sequence design and analysis feature in benchling molecular biology, as well as AlphaFold Beta. We're happy to demo this or other sequence design functionalities live and help you decide if this is the right solution for your research. You can request a demo of these new capabilities using the link in the docs section or visit our molecular biology product page on benchling.com. For those in the benchling community of users, you can reach out to your benchling representative for more details. Thank you for your time and attention. I'll send it back to you, Shauna.
Thanks, Johan. Another fantastic presentation. A quick reminder to our attendees, if you have any questions about any of the mRNA or sequence design things that were just presented, feel free to ask them in the chat and we'll get right to this. And at the end of the webinar, we're going to have a little poll. We'd really appreciate your feedback so we can make sure we're delivering the information you need in these kinds of webinars. For the last presentation today, we'd like to continue the discussion from our webinar last quarter on how biology's modern LIMS from Benchling is helping researchers to move their science forward. And we gave you a peek into some of the new capabilities in workflows and large data management. And today, my colleague Wendy will now share some exciting new capabilities in workflows. Take it away, Wendy.
Thank you, Shauna. Hi, my name is Wendy Ochoa, and I'm very excited to be able to share how powerful Benchling is for both research and development. I will be sharing information about Benchling LIMS capabilities today. I will highlight how our new workflows application now allows the team to design and execute complex processes using the shared scientific data you are currently generating in Benchling. In today's biotech organization, the assumption is that both research and development team will work in a shared cloud-based solution that combine the best capabilities of both ELN and LIMS. Teams creating advanced biotech products should be working in modern software built for the complexity of large biomolecules across the life cycle. Benchling is now the leader in the R&D Cloud category, supporting both the more flexible needs of those conducting exploratory work and also configurable to structure the process-driven needs for teams working with defined protocols. Benchling is able to power this connected and collaborative work thanks to the introduction of the workflows application unveiled early this year. As a quick recap, the workflows application was designed to truly move your science forward, helping the teams to not only capture R&D data for samples and experiments, but also to connect all lab activities from simple requests to orchestrated processes. Schedule experiments, assays, and runs, then capturing and analyzing the results once completed, and optimize workflow as the work progresses. By doing all this process-driven work in Benchling, workflows transform Benchling from a system of record to an engine of collaboration and insights. This means rather than having data simply accessible in a shared system, workflows uses the same data to power the work itself. Workflows improves how efficiently teams can complete their work. Programs can now run more efficiently, increase overall velocity, and improve decision-making by interconnecting results and operational information. Some example use case include simplifying end-to-end sample management, streamlining testing and screening, and optimizing materials production. Teams can begin by working on simple tasks like sample, assay, or material request. And then within the same solution, they can scale up the complexity of processes supported to include complete planning and scheduling, creating testing procedures, and collating results for analysis, for example. This can be for processes within and across teams. I will jump into the product demo momentarily, focusing on processes designed for a QC lab to highlight this one use case. This demo will touch on many different capabilities within workflows, which are organized into 3 different buckets: design tools, tools to manage workflows in real time, and dashboards and notification. You may have seen last quarter What's New webinar where my colleague Chelsea Kowalski demoed the Workflows Manager and dashboards and notifications. Today, I will focus on the latest functionality for process design in particular. During the demo, we're going to see 3 main scenes. In the first scene, we will see how the production team initiates a request of a complex QC testing workflow. The production team will add some customization to the process based on the samples. In the second scene, we will see how the QC team is notified and executes an orchestrated testing workflow. The system keeps track of the chain of custody of each of the samples and aliquots. The third scene, we'll see how at all times teams have visibility into the status of the process, task, and results. Let's jump into the platform. I'm going to start the demo today at a point in which the production team has finalized the production of a new lot. In the same document that the production team has used to capture information about the details of the experiment, the details of the lot, inventory of the lot, is going to be used to actually start a request to the QC team to run some tests. So you can see here this initial form transfer all the information from the production team to the QC team, connecting those 2 teams. and it has the vial, the ID. So there's very little risk on actually sending the wrong vial, the wrong ID to the QC team. You can see here actually the new flowchart builder functionality in Benchling. In most cases, these workflow, the steps the team is going to follow might be locked and might be reviewed and approved. But and this will support very well those teams that need those defined processes. However, this flowchart builder also support teams that need more flexibility. And then they need the flexibility of changing this process as we are asking the team to process this request. And in this case, we will see this button here, and we'll have the option to change and to reconfigure this workflow. Let's assume in this case, based on the type of sample, I don't think I need potency test. So I'm going to delete this test, but what I need is actually an HPLC test instead. All I have to do is drag this test from the available test, connect inputs and outputs, and here I have my new actually workflow defined for the QC team to process. So as you can see, Benchling can support both scenarios, the scenario in which the workflow is structured and defined, but also the flexibility of those teams that need this maybe to test different processes. As we create this request, the system is going to assign a new ID and unique ID to the workflow itself, under which all the activities associated with that workflow are going to be under. And now you can see here actually how the sample has automatically moved to be part of the first task of the workflow, in this case, aliquoting. The team in charge of aliquoting will receive a notification with a link to the task itself. And as they access that task, what they can do here is maybe assign to themselves, to other users, and schedule the task for the day is going to be processed. But also from here, the team, the person responsible for this task is going to be able to execute this task. Usually tasks have a templatized form that is going to guide the process, the task execution. And in this case, we have all the information we need to aliquot the sample that came from the production team. Some of the information was just predefined for demo purposes, but in general, what you can see here is you have the inputs that come from the production team, and you will have here options for the QC team to set up information about those aliquots that are going to be prepared. In this case, we can set up inventory information. We can also set up like sample owners, authorized users for each of the aliquots, keeping track of the full chain of custody of each of the samples. We are also determining or assigning tests for each of the aliquots that we are preparing. And as we transfer this information to the system will create a unique and printable barcode for each of the aliquots that we prepare. We will connect these vials with the task, set up maybe testing urgency. And as we do so, we can mark right from here as well that the task has been completed. This will send a notification to the teams that come after, to the production team, notifying that the task has been completed. And as we see in the workflow panel, we are going to see that this task is completed, and now the samples move along for the corresponding test. What I'm going to show you now is actually a complete test. Similar test, but in this case, you can see that all the tests have been completed. And so anybody involved in this workflow, either from the production team or the QC team, can at all times actually understand and review what happened during those tests. So if I want to know a little more details about the HPLC test, I can come here and even access the execution entry and how the text was processed, the results of the process, etc. I can also access maybe information about a summary, maybe a summary of all the tests that were done, who did it, when were done, and the results for those tests. And one more kind of the output, seeing that all those tests were reviewed by the QC team and approved. All this information is capturing in Benchling, centralized in the same place. And the communication between the teams, the production team and the QC team and other teams is also in Benchling. So you can easily see that all this information, not only of the QC workflows, but any workflow that is set in the process, in the project, in the platform will be here. Here we have an example of a dashboard in which I can see all the different tests that were submitted to the QC team and the status of all those workflows. I can see as well easily, like maybe I want to have information about all the tasks that were assigned to me and the status of all those tasks. So I can see here that most of the tasks were completed, one failed, and one is still pending. And again, if I want to know more, I need more information about how these samples or these tests were processed, I can always go and access that document that was used to actually capture all the details of that particular task. So what we have seen during this demonstration is how the new workflows flowchart builder allow development teams to configure the structure and lock down workflows, but also supports research flexibility. How workflows connect teams and streamline the communication and task completion. How Benchling allows teams to easily set and track chain of custody of each sample and each aliquot, and how centralizing all the information related to samples, tasks, teams, and assays empowers the organization to do more with the data. Everything you saw today is currently available for customers with our notebook, registry, inventory, and workflows, including the new flowchart features I showed. Please reach out to your designated Benchling representative for more information about using these capabilities to support LIMS use cases. If you are not currently using Benchling or haven't purchased workflows, we are happy to demo this functionality live and help you decide whether it's the right solution for your team. Lastly, you can read more about these modern LIMS and Benchling workflows by following the link to our blog or visiting the workflows product page on benchling.com. Thank you, everyone, and I'll give it back to you, Shauna.
Thanks, Wendy. We're actually going to start Q&A now. So I'm going to bring the amazing panelists we had today back up on the stage. Remember, you can always ask additional questions up in the Q&A box up at the right side of your screen. I think this first one actually is for you, Zach. Our customers really want to know, can I import my own monomers into Benchling to examine?
Yeah, great question. We definitely get that a lot. And the answer is yes. We're absolutely happy to help you import your monomers into your Benchling tenant so you can start using them in your sequences. Just reach out to your customer success manager to learn more about how.
Awesome, Zach, don't go too far. We have another one for you. And someone thinks maybe they missed it in the demo, but they want to know if we can automatically calculate molecular weights of modified sequences.
Absolutely. Yeah, any modified sequence, whether it's a full sequence or an oligo, can have a field for computing its modification-aware molecular weight. And that'll be updated as you make modification changes. So enjoy.
Amazing. I'm excited. I actually knew the answer to that one. I'm new, and it's so great when I like, yay. Johan, we've got one for you. Are there API endpoints for our DNA alignment tools?
Yes, we have all our endpoints for our DNA alignments listed under the nucleotide alignments sections at our API reference documentation.
Cool. Wendy, one for you. What is the max number of workflow tasks that can be created from a single task?
Oh, that's an interesting question. So really a single task can be used in as many workflows as you want to. A single task is configured as an independent unit with their inputs, outputs. So yeah, you can either include it in a multiple task workflow or even use it as a single task workflow.
Great. Another one for me. One of our customers wants to know, this is seeing workflow and they're wondering, can they use it as a project management tool? Do you have customers, who are using it that way?
Yeah, definitely. Actually, Workflows was indeed built to support project management among and across teams. So especially for those projects that involve collaboration around samples, assays, and results and instruments. So because it's fully integrated with other applications, so you have visibility into not only the requester, the assignee, the schedule, the status of completion, but also visibility into the samples, the resources. And we have customers that have been using Workflows for a wide variety of teams, like from like molecular biology teams working on plasmid prep, to quality teams running QC testing, analytical teams that support all the other teams in the organization, process development. I mean, yeah, I think it's a tool that can be used by many different teams in many different use cases.
Yeah, I've been so impressed with how flexible and powerful the new workflows are. It's great. Another question came in. Someone wants to know if they can rerun an alignment that they performed if they modify one of the sequences. Johan, I think this one might be for you.
Absolutely. Yeah, thanks for the question. So we get this question a lot. And yes, you can update and rerun alignments if there's a change to the sequence. You can also rerun alignment in case you want to have a different gap penalty or gap extension penalty and see what the alignment will look like then. So absolutely, that can be done.
All right. I think this one is for you, Zach. Are there any unique RNA fields or biochemical properties that are displayed specific to the RNA objects?
Yeah, good question. Whoever asked that, I'd love to learn more about what you're thinking. But in general, we have, as I mentioned before, the ability to display modification-aware fields like the molecular weight. You can also have things like extinction coefficient calculated. And of course, if you have a specific syntax like Helm that you want to have it exported as, that's also an option specific to RNA fields.
That's great. Time for one more question, Wendy. I think that you get the last one here. We have a question that's coming in about any improvements to permissions on workflows. There's projects where they want to share their workflow processes, but they don't want others to change or edit. Is there a way to assign privileges to edit or view the processes we've built in workflow?
Yeah, great question. So permissions can be set at many different levels for workflows, at the configuration level and then at the execution level too. So you can kind of decide who can edit, who can configure, who can even run the workflow. But also think about, like, because the workflows are associated with projects, all the permissions that are set for that particular project will be applied to the workflow itself.
It's great. Sadly, that is all the time we have for questions. We'll definitely get back to you, though, if you asked a question in the chat and we didn't have time to answer it today. Thank you again for joining us. Please take our brief survey. We know from last time that we got a great bunch of feedback, so we want to make sure that in the poll tab, you just take a few minutes and let us know how we did today and how we can best serve your needs. We look forward to seeing you next quarter at our next What's New webinar. Have a great rest of your day.